Lesson 9.1 is on geometric sequences. In this lesson, we'll recognize and extend geometric sequences, and then we'll also find the nth term of a geometric sequence. So the table here shows the heights of a bungee jumper's bounces. So bounce 1 was 200 feet, 2 was 80, 3 was 32. The height of the bounces shown in the table form a geometric sequence. In a geometric sequence, the ratio of successive terms is the same number, which we are going to identify as R, and that's called the common ratio. Geometric sequences can be thought of as functions. The term number or position in the sequence is the input, and the term itself is the output. So here, the first position was 3, and that's a sub n. Or a sub 1, the 1 tells us the term in the sequence. Second position is 6, so a sub 2. Third position is the number 12, a sub 3. Fourth position, the term is 24, which is a sub 4. The variable a is often used to represent terms in a sequence. The variable a with the little 4 next to it is read a sub 4, and it's the fourth term in the sequence. So we're going to look at what the formula is to find a term of a geometric sequence. So to find a term in a geometric sequence, you multiply the previous term by r, so that common difference. And when we find a term of geometric sequence, the nth term of a geometric sequence with a common ratio r is defined as a sub n equals a sub n minus 1 times r. So you just take the previous term and multiply it by that common ratio. So for a and b, we're going to find the common ratio first, and then we're going to use that common ratio to find the next 3 terms. So to find the common difference, you look how you're going from each term to the other. So I'm going from 1 to 3 by multiplying by 3. And you can do this by finding the ratio of the 2 terms next to each other. So 27 divided by 9 gives me 3. The 9 divided by 3 gives me 3. And then 3 divided by 1 gives me 3. So that means I'm taking the term before and multiplying it by 3 to get the next term. So here, to get the next terms, I would take 27 and multiply that by 3. 27 times 3 is 81. Then I'll take 81 and multiply that by 3. That will give me 243. And then I would take 243, multiply that by 3 to get my next term, which is 729. So I'm taking my terms and multiplying by 3. For B, I have negative 16, 4, negative 1, and 1/4. So I'm going to do the same thing. I'm going to look at the ratios to find that common difference R. So 1/4 divided by negative 1, that's going to give me negative 1/4. And then negative 1 over 4 is equal to negative 1/4. And then 4 over negative 16 simplifies to negative 1/4. So that means R here, our common difference is negative 1/4. So to get the next term, I'm going to take 1/4 and multiply that by negative 1/4. So I'm going to get negative 1/8. And then I take that and multiply that by negative 1/4. And negative times a negative will be a positive. 1 times 1, the numerators will give me 1, and 8 times 4 is 32. Then I'll take this, multiply it by negative 1/4, and negative times a positive will be a negative. Numerators, 1 times 1 is 1, and then 4 times 32 will give me 128. So those would be the next 3 terms in the sequence. So you find your common difference, and then multiply by your common difference to get your next terms. Now we're going to look at 2 check it out problems. You're going to find the next 3 terms in each geometric sequence. So go ahead, take a moment, pause the video, and then resume when you're ready to check your answer. So here, 5, negative 10, 20, negative 40. So let's find our ratios. So I'm going to do negative 40 over 20. That gives me negative 2. 20 over negative 10 gives me negative 2. And then negative 10 over 5 gives me negative 2. So that means my common difference here is negative 2. So to get my next three terms, I'm going to start by multiplying negative 40 by negative 2. That'll give me positive 80. I'll multiply by negative 2 to get negative 160. Multiply by negative 2 again, and that's going to give me positive 320. For B, I have 512, 384, and 288. So I'm going to look at my ratios. So 288 over 384, that gives me 0.75 or 3/4. 384 divided by 512 also gives me 0.75. So that means my R, my common difference, is 0.75. So I'm going to start by taking 288, multiplying that by 0.75, and that's going to give me 216. I'm going to take this, multiply it by 0.75. 216 times 0.75 is 162. Times 0.75 again, I get 121.5. To find the output A sub n of a geometric sequence, when n is a large number, you need an equation or a function rule. You're not going to want to keep on multiplying by that common difference until you get that term in your sequence. So the pattern in the table shows that to get the nth term, you multiply the first term by the common ratio raised to the power n minus 1. So whatever term you're finding, you take away 1 and raise that common difference to that power. So if the first term of a geometric sequence is a sub 1, the nth term is a sub n, and the common ratio is n, then this is going to be our equation. A sub n, their nth term, equals a sub 1, the first term, times r, the common difference, raised to the n minus 1 power, where n is the number of the term that you're finding. So this formula is going to be really important for you to know. So for A, the first term of a geometric sequence is 128. The common ratio is 0.5. What is the 10th term of the sequence? So the first term is 128. So that means my A sub 1 is 128. My common ratio is 0.5. So that means R is 0.5. And we're finding the 10th term. So n is going to equal 10. So A sub 10 equals A sub 1, which is 128, times R, which is our 0.5, to the n minus 1. So n is 10, so we're going to have 10 minus 1. So that means we're going to have 128 times 0.5 to the 9th power. So we have to evaluate 0.5 to the 9th power first. Okay, and here we're going to have to estimate a little bit because this number is not going to be so nice. So I'm going to show you on my calculator what I get. So we're going to get 0.5, and then we're going to raise that to the 9th power. So you're going to get this very long number. So we're going to get 128, and it's times 0.001953125. And then we're going to take that and multiply it by 128. So we get 0.25. So that means the 10th term is the number 0.25. So now we're going to look at the next example. And it looks like I accidentally reversed the order of these. I have C coming first and then B, and I apologize for that. I'm going to go ahead and do B first, and then we'll come back and do C. So for B, we have for a geometric sequence, A sub 1 equals 8, and R equals 3. Find the 5th term. So we know A sub 1 equals 8, r equals 3, and n is going to be 5. So we're going to use our formula. We're finding a sub 5, and it's going to equal a sub 1, which is 8, times r, 3, raised to the n minus 1 power, so 5 minus 1. So 5 minus 1 is going to give us 4, so we have 8 times 3 to the 4th power. So we're going to do 3 to the 4th power first, which is 81. So we're going to have 8 times 81, which will give us 648. So fifth term is 648. So now we're going to go look at C. So it says, what is the 13th term of the geometric sequence 8, negative 16, 32, negative 64? So we need to identify a sub 1. So a sub 1 is 8. We need to find r. So we have to look and find our common difference. So we don't know r yet. And then n is going to be 13. So to find your common difference, here you want to do your ratios. So negative 64 over 32, that will give us negative 32. And then 32 over negative 16 also gives us negative 2. And negative 16 over 8 gives us negative 2. So r equals negative 2. So now we can go and use our formula. So we're finding the 13th term, so a sub 13 equals a sub 1, which is 8, times r, which is negative 2, raised to the n minus 1 power, so 13 minus 1. And the 13 minus 1 will give us 12, so we'll have 8 times negative 2 to the 12th power. When you put negative 2 to the 12th power in your calculator, remember to put the negative 2 in parentheses because you're raising negative 2 to that power. So I get 4,096. If you don't put this in parentheses, it's going to raise 2 to the 12th power and then keep that negative term. So we're going to have 8 times 4,096, and then we just have to multiply by 8. So we get the number 32,768. So 13th term here is a very large number. It's 32,768. So now there is a check it out problem for you to do. It says, what is the 8th term of the sequence 1,000, 500, 250, 125? So go ahead, take a moment, pause the video, and then resume when you're ready to check your answer. So first, I know a sub 1 is equal to 1,000. I need to go find my common ratio, and then my n is going to be 8. So 125 divided by 250 is going to give me a common difference of 0.5. 250 divided by 500 will also give me 0.5, and 500 divided by 1,000 gives me 0.5. So that means my r is equal to 0.5. So we're going to find a sub 8, and that's going to equal 1,000 times 0.5 raised to the 8 minus 1 power. So we're going to have 1,000 times 0.5 to the 7th power. So now we're going to do 0.5 raised to the 7th power. Oops, not 0.05, sorry, 0.5 to the 7th power. So we're going to get 1,000 equals 1,000 times. So 1,000 times, and I just put it in my calculator, we get 0.0078125. And then we multiply that by 1,000. So we get 7.8125. So our 8th term is 7.8125. So now we're going to go ahead and look at example 3. So in example 3, it says a bungee jumper jumps from a bridge. The diagram shows the bungee jumper's height above the ground at the top of each bounce. The heights form a geometric sequence. What is the bungee jumper's height at the top of the 5th bounce? So we know the first bounce is 200, second is 80, third is 32. So that means our A sub 1, our starting position is 200. We need to go and find our R, and then our N is going to be 5. So let's do our ratios. So 32 over 80. 32 divided by 80 gives us 0.4. And then 80 over 200. 80 divided by 200 also gives us 0.4. Okay, so that means our ratio, our common difference, is equal to 0.4. So now I'm going to go find that 5th bounce. So we're going to have A sub 5 equals 200 times 0.4 to the power 5 minus 1. So we'll have 200 times 0.4 to the 4th power. So we're going to raise 0.4 to the 4th power. So we'll get 200 times 0.0256. Multiply that by 200, and we get 5.12. So height of the 5th bounce. So height would be 5.12 feet. So the height of that 5th bounce is 5.12 feet. So now there is a check it out problem for you to do. It says the table shows a car's value for 3 years after it is purchased. The values form a geometric sequence. How much will the car be in the 10th year? So go ahead, take a moment, pause the video, and then resume when you're ready to check your answer. So we know that A sub 1, our first year, is 10,000. We need to go find our common difference in a second, and then we're finding after the 10th year. So N is going to equal 10. So doing our ratios, we're going to do 6,400 over 8,000, and that gives us 0.8, and 8,000 over 10,000 gives us 0.8. So our common difference, our ratio, is 0.8. So now to find A sub 10, we're going to do 10,000 times 0.8 to the 10 minus 1 power. So we're going to have 10,000 times 0.8 to the 9th power. So 0.8 to the 9th power. So we're going to get a not so nice number, but I'm going to go ahead and write that down so you have that for your notes. So 0.134217728. We're going to take that and multiply that by 10,000. And we get 1,342.17728. And for this, we're talking about money. So money, we round to the 10th place. So the car will cost 1,342 point, that 7 would round up because that's 7, so 0.18. So $1,342.18 would be that cost after the 10th year.